Hello, I'm Scott Blair. I'm the inventor of the WheelFit Test Fit tool. I want to thank you for purchasing your WheelFit Ultimate Kit or your Pro Kit. This instructional video will show you how to assemble either of your kits, talk about all the dimensions of the tool and why things are the way they are, and then we're going to discuss how to use them on different types of suspensions. Behind this instructional video is an educational portion that will discuss all the terminology and dimensions needed for you to build your custom wheel accurately and be able to communicate effectively with the manufacturer. Our phone number and website are at the end of the video. If you have any technical questions, please give us a call. Let's get started. We're going to get started with the faceplates first. If you purchased a Pro 45 kit, your kit will have this faceplate right here. You'll notice that this faceplate will fit your common 4-lug and 5-lug applications. It has a small bore, so it'll fit from 4-100 up to 4-130 millimeters, and 5-100 up to around 5-on-5. Whatever lug nuts were on the vehicle, that's what will work with your tool. Now, if you're working on an early 60s or 70s GM car or truck that had 7/16 studs, you'll want to maybe use a washer over the stud to give the lug nut a little bit more room to seat, because the lug nuts tend to be a little small and they may tend to sink down into the lug hole. This faceplate will also fit over the large 5/8 studs common on your Pro Street and full race applications as well. If you purchased a Pro 56 kit, you've got the 5 and 6 lug faceplate that will fit all the way up to 5-on-150 and 6-on-5.5. If you purchased an Ultimate kit, you'll have both the 4 and 5 lug and the 5 and 6 lug faceplates. We also offer an 8 lug faceplate for 3/4 ton trucks. As for your vertical extensions, the wheel fit will extend from 14 inches to 20 inches in tire bead diameter. It does that by adjusting the bolt holes right through here and matching them up to the holes in the faceplate. 14 is here near the top and 20 is here at the bottom. We also offer optional extensions that will go from 21 inch to 28 inch in tire bead diameter. You've got a pair of long horizontal extensions. There's a series of peaks and valleys along this part. Each of the peaks and valleys represents a 1/2 of an inch. The tool will start off at 6.5 inches in width and will extend all the way up to 16. You'll also notice that there is an adjustable bead clamp on the tool, and you loosen it up by the Phillips head screw from underneath. You place this tool onto your tire bead and then secure this screw so that the tool will grasp the tire that you're looking to test fit. Also notice this horizontal piece has an engraved ruler mark. This ruler mark indicates your backside setting as well as the overall width that the tool is set up at. Now here we have the short horizontal extension. Again, it has an adjustable bead clamp that can be loosened and tightened from the screw underneath. This part will sit on top of the long horizontal, and this tooth underneath it is what fits into the valley on the long horizontal. This is how it stays secure in its width while you're adjusting your offset. Now that you know about the individual parts, let me show you how to assemble it in an actual tire. The first thing that you're going to do is take the horizontal extensions, place them over the bead of the tire, hold the bead clamp firmly against the tire bead, and then start turning on the screw until it tightens up and that the tool grasps the tire bead firmly. Now that we've set all of our bead clamps, let's assemble the tool so that they can be placed inside the tire. The first thing that you want to do is install your short vertical extension into the bottom of the long horizontal extension and then place the short horizontal extension on top of that so that they line up. Next, use your 1/4x20 bolt that's supplied, thread it through the hole in both of the grooves, and then secure it with one of the black knobs. Once you've done that, take another bolt and secure it between just the two horizontal pieces and use a wing nut to put it together. This is important. By using this bolt and wing nut to secure both horizontal pieces together, that allows us to loosen the knob and adjust our backside setting completely independently of the width. Okay, I've got the other half put together, and what I like to do is place the two parts on top of each other so that I know that they look identical. This means I've got the exact same width and the exact same backside setting set up on both halves of the tool. Now here's something that can be useful for you. With the wheel fit, you can take the vertical extension, which I have with the short leg pointing toward the street. You can actually loosen up your knob and flip this around the other way. So if I needed a very high offset wheel, I can actually take the short leg, point it toward the rear, and be able to move the offset further toward the street, gaining more flexibility in the tool. So I've set the tool up with the short leg pointing toward the street, but I could just as easily have turned it around and had it pointing toward the inside and then moved forward for more clearance or higher offset, whichever the case may be. I would just simply would have taken the nut and the bolt that holds the two horizontal pieces together and moved it to the other side to give myself plenty of room to move up and down the length of the tool for maximum benefit, and then take advantage of all of the options and offsets that are available within the constraints of the tool. Once I have one half of the tool assembled and put together, I assemble the other half and make it look exactly identical to this half. I set it at the same width and the same backside setting. In our example, we're going to set the tool up for a 9-inch wheel, which means that the tool will be set for a 10-inch wide overall width, and we're going to use a very common 4-inch backside setting. Okay, now that we know that we have both halves of the tool identical, we're going to bolt one half up to the faceplate. So we've chosen the correct faceplate for our application. We're going to bring both bolts from the rear. We're going to take one half of the tool, place it in the correct diameter, which in this case is 18 for this tire, and secure it with the wing nuts. Also, something I want to mention right here. This is very important. As you see here on our tool, when the vertical extension lines up with the ruler mark, the back of the vertical extension is not your backside setting. Your backside setting is where the tool makes contact with the vehicle. In this case, our faceplates are exactly 1/2 inch thick. So right here, the back of our vertical extension is lined up at 4.5 inches. We subtract the 1/2 inch for the faceplate, and imagine a vertical plane coming up and intersecting our ruler mark, which in this case would be 4 inches. Make sure that you remember to do that. If you happen to need to stack some spacers behind the faceplate to clear a large brake caliper, just remember, ever how many spacers that you stack behind the faceplate, subtract that much more off your backside setting so that you've got an accurate fitment. Okay, now that we have everything assembled, let's set our tire back up here. I prefer to install the tool into my tire with the tire laying flat. Watch this technique. I think you'll find it very easy. We're going to take the part of the tool that includes the faceplate, and we're going to go ahead and install it into the tire. I'm going to have to spread the beads just slightly to make it fit. Now, because we set our bead clamps earlier, it's nice and snug and it's not falling out of the tire. Now, I'm going to get the other half of the tool and get it ready to slide in just like this. And here's what I like to do. Go in at an angle, spread the beads apart, take one bolt, come in from the rear of the faceplate, move the two parts offset to each other slightly until they line up, push the first bolt through, and then rotate it back into place like this, and then secure it with the wing nuts like so. Now that we've done that, it's good and snug inside the tire. It's not going to go anywhere. And when we bolt it to the vehicle, we're able to move that backside setting back and forth like we want to determine the exact fitment to make the widest tire possible fit without rubbing. Let's go put it on the car. Okay, I've moved the car out of the garage onto the driveway to demonstrate that the tool is designed to be used in this type of an environment. You don't need any special tools. You don't have to have a lift. You work with the car right on the ground. Okay? I've got the tire and the tool already clamped together as we did earlier, and we're going to bolt it to the car, and I'm going to demonstrate how to use the tool on the car to change your backside setting and be able to determine how much tire that you can actually get on that application. Okay, now we've got our wheel off. We're going to place our jack underneath the lower control arm so that we can set the car at ride height, and then we're going to place in our jack stand as a safety device in case our main jack fails. The wheel fit tool is not designed to support the weight of the vehicle. It is a measuring tool only. Only use a rug wrench to snug fit the lug nuts onto the wheel fit tool. Don't use an impact gun. And now to place our safety jack. Okay, we've got the wheel fit bolted up to our vehicle. Now I set this tool up purposefully with a low offset, knowing that this car takes a high offset, to demonstrate how you adjust it on the vehicle. Now before we get started, I've got a small bottle jack underneath the lower control arm, as you can see here, and I also have a jack in place in case my small bottle jack were to fail for some reason. I've got a safety catch. Now that I've got it bolted up on the vehicle, you can see with this offset that I've got a lot of tire sticking outside the fender well. If this was your application and you're working on it, if you turn the wheels lock to lock right here or rotate 360 degrees, you're going to find that the tire is going to rub and bump into the fender well here, probably back here. So even though this is over exemplified, you get to understand what I'm trying to accomplish here to demonstrate. Now, the correct offset on this particular application is a high positive. So what I'm going to do is I'm going to reach in and I'm going to loosen the two knobs that we demonstrated earlier. And in doing so, I can move the tool back and go to a higher offset and pull the tire back up underneath the vehicle. Now, when I get it exactly where I need to, I can take and I can turn the wheel lock to lock, rotate this tire, and at that point I can check my clearances on the inside and on the outside. When everything fits exactly the way you want, look at the side of the tool, and that ruler mark will tell you exactly where the backside setting needs to be to build your wheel.